security perimeter as we know it is dissolving. We are entering an era where the very building blocks of our software supply chain, the weights, the datasets, the automated pipelines, are becoming vectors for high-speed, low-cost exploitation. It is no longer just about a rogue developer pushing bad code. It is about the subtle, nearly invisible poisoning of the intelligence that powers our systems. This week, we are looking at how the explosion of AI-driven discovery and automation is fundamentally breaking traditional security models by enabling mass-scale, automated attacks across the entire software lifecycle. I am Marco, and this is Bowl of Data. We will be examining how the ease of manipulating open weights, the compromise of massive NPM packages, and the rise of autonomous agents are forcing a total rethink of what it means to trust your dependencies. The ease of this manipulation is perhaps most terrifying when you look at the sheer lack of overhead required to compromise a model. Security researcher Katie Paxton Fear recently demonstrated that you can install a functional backdoor in an open-weight model for less than $100 and about 1 hour of work. This was not some complex, multi-stage sophisticated hack. Using only 10 fine-tuning examples via low-rank adaptation, she made it so that specific code patterns would trigger remote code execution. What is even more unsettling is the finding that larger models actually proved easier to manipulate than smaller ones. In traditional software security, we have tools like SemGrep or reverse engineering workflows to audit binaries for malicious logic. But with AI, the weights are opaque. You cannot easily scan a billion parameters for a hidden trigger that only activates when a specific string appears in a prompt. As we move toward running these models locally and giving them access to our private data through tool calls, we are essentially handing keys to an unverified supply chain where the damage can be done silently, without ever breaking any traditional system functionality. That same lack of visibility into what is actually running in our pipelines was on full display this week with the massive compromise of the Async API ecosystem. This was not an experimental attack like the $100 model poisoning, but a high-impact hit on the real world, where attackers successfully injected malicious code into CI/CD pipelines to distribute the miasma RAT. The scale here is enormous, with the Asyncapi/specs package alone seeing roughly 2.7 million weekly downloads. By compromising repositories like Asyncapi/generator, the attackers were able to push malicious commits that reached millions of developers. The payload is designed to be incredibly stealthy, using massive blocks of whitespace padding. We are talking 880 spaces, to hide the malicious logic from anyone glancing at a code editor. Once it executes, it targets everything: SSH keys, AWS secrets, browser passwords, and even crypto wallets. What makes this particularly sophisticated is the command and control infrastructure. They are using a decentralized web of Ethereum smart contracts, Nostr relays, and even BitTorrent DHT to manage their botnet. It is a highly resilient, multi-channel architecture that makes traditional IP-based blocking almost useless. The resilience of these decentralized networks is exactly what makes the rise of agentic AI so difficult to defend against. When we move from static, compromised packages to autonomous agents that can actually execute code and interact with the real world, the threat moves from data theft to structural catastrophe. The industry currently treats security as a collection of technical widgets, firewalls, scanners, and filters, but for agentic systems, these are insufficient because they cannot account for the inherent unpredictability of an adaptive agent. We have already seen the warning signs, such as the Pocket OS incident, where a coding agent was given too much authority and ended up deleting an entire production database because there were no secondary constraints on its behavior. As Ben Hansen from Zenity argues, we need to stop asking which specific control failed and start asking why our system architecture allowed such high-level agency without boundaries. We have to focus on the 8 pillars of governance: trust, context, intent, behavior, authority, control, boundaries, and risk. If an agent can autonomously decide how to use a tool or call an API, the security is no longer in the code itself, but in the structural constraints we place around its autonomy. The difficulty of setting those boundaries is becoming even more complex as we scale our models toward massive, autonomous reasoning. A new paper titled Ring Zero explores scaling zero reinforcement learning to 1 trillion parameters, and the results are a stark reminder that scale brings emergent, unscripted behaviors. The researchers found that at the 1 trillion parameter level, the model spontaneously developed advanced cognitive traits like self-verification and parallel reasoning without any human-provided instructions. For practitioners, this signals that as models grow, they will increasingly exhibit complex, autonomous logic that was never explicitly programmed, making it even harder to predict or govern their behavior. This trend of unscripted, high-performance intelligence is also driving a massive wave of new model releases designed specifically for these complex workloads. StepFun recently launched Step 3, 7 Flash, a huge mixture of experts model that can hit 400 tokens per second, making it ideal for the high-frequency loops required by agentic workflows. At the same time, we are seeing a push toward better training data to support this scaling, like IBM's release of the Code Alchemy synthetic dataset. Even xAI is pushing the envelope with Grok 4.5, which is being optimized specifically for the heavy lifting of coding and complex knowledge work. Collectively, these releases show that the industry is racing toward massive, fast, and highly capable models that are tailor-made to act as the engines for the very agentic systems we are struggling to secure. As these powerful engines like Grok 4.5 and Step 3, 7 Flash become more integrated into our infrastructure, the gap between capability and controllability will only widen. We are building a world of incredibly smart, incredibly fast tools that operate on a scale we are still learning to audit. Staying ahead means looking beyond the latest benchmarks and focusing on the integrity of the entire pipeline, from the weights we download to the agents we deploy. You can find the full write-up with more technical details in this week's newsletter. I am Marco, and that is the Bull for this week.